I'm going to walk you through building a clean, professional player controller that works seamlessly with any character that implements its interface. We'll cover camera relative movement, cursor aiming, projectile attacks, and a smooth camera zoom, all built with a clear separation between input and gameplay logic. A typical top-down character would have two main actions, a move action and a primary attack action. So we're going to start with that. In my content folder, I'm going to create a new folder called unsorted, and I'm just going to put an underscore in the front so that it puts ahead to the front of all the other folders. And in this folder is where I'll put everything for what we're going to be working on, and just to keep it all together, I'll sort it out into the proper areas later on. So to begin with the input actions we'll need from the player to interpret into the controller, we'll want to have those move and attack inputs. So I'm going to right click into the folder area, go to input, and create a new input action. This will represent the action that the player can put into the game to cause something to happen. So I'm going to make this one the move action. If we open this up, we'll take a look at it. For our case, we're only going to be really making use of the value types and the modifiers. Not necessarily in the move, but for all of our input actions that we'll cover. So if you'd like to learn any more about what's going on in here, I would recommend reading the documentation for input actions to best understand all of the possibilities you have for working with an input action. In the case of our move action, this is going to be not a digital bool, but an axis 2D, because we'll want to be working with an up and down axis as well as a left and right axis. So you can think of WASD or an analog joystick to be controlling this. So we'll select axis 2D and we can save this and close it. Our move is ready to go. Then we'll want our primary attack. So we'll do the same thing, create a new input action, name this primary attack. We'll open this up, and for this one we will use the digital bool. We only care if the input is either active or inactive. We don't need a float value, we don't need two float values, and we certainly don't need three. So we can save this as it is, defaults are good to go, and we can close this out. Next, we'll want to make an input mapping context to hold these input actions and give them keys to drive them and any additional behavior that we might want around them. So again, in input, we can create the input mapping context. I'll name this IMC underscore top down. I'll open this up, and we have our default key mappings here. If we expand this, we have our mappings, and we can use the plus button to add action mappings. So when we click this, it adds another arrow here for us to drop it down, and we have a none bar here. If we open this up, we have our two input actions that we've created. So let's select the move, and now we can uncollapse this, and we have a keyboard with a none that represents the key that is currently set to, and a trash can to remove it. So I'm going to add that back, uncollapse it again, and we can click the keyboard to easily set the key for what we want this value to represent. So I'm going to hit the keyboard and hit W, and now we have W bound to this mapping. And if we uncollapse this, we can see triggers and modifiers. And this is where we'll be adding our first modifier. For our W modifier, we'll add the modifier, and we'll want to select the swizzle input axis values, useful to map a one-dimension input into the y-axis of a 2D action. And that's exactly what we want from this. So we'll select this, and the order is defaultly YXW. Swap X and Y axis, useful for binding 1D inputs to the y-axis for 2D actions. Let's stop here for a moment to make sure we understand how this is really working behind the scenes. So we have our move input action, which is literally just a name and a value type of axis 2D. And then we have our keyboard with keys like W, A, S, and D. A key is only a true or false value, best represented as the digital bool. It's either down or it's not down. So we can only really get a 0 or a 1 from a key. And by default, with no modifiers here, pressing W or any other key on your keyboard is going to result in a 1 on the first axis value if the type is a 2D axis. So this is where the swizzle comes in to swap those X and Y axes. Now the value ends up on the Y, and we're able to use these very binary keys in more meaningful ways to interpret more complicated inputs. So knowing that, moving forward, you could try to figure out the rest of WASD on your own and see if you're right as you go ahead. So I'll go on and add the next key here. Oh, I never added move back to this. And we'll add another key, set this one to S, and similarly, this is going to be the vertical value matching W's opposite. So we'll add the swizzle here, keep it on the Y again. The only difference is that it is going to represent the negative of the W. So we can add another modifier here, go to negate, and uncheck X and Z as this is strictly along the Y axis. So now we've taken another of our binary 0, 1 keys, translated it onto the y-axis, as well as negated it. So now we've given 2 of our binary keys a full range of motion from -1 to 0 to 1. And now we can do the same thing with A and D. A, D, these are going to be our x-axes, and by default, based on how we understand our keys to work, these are going to go directly to the x-axis by default. So A, being our negative representation of the x-axis, we can just add the negate modifier only on the x-axis, and D is the positive. We need no modifiers for this, as it's already on the X and it's the positive value. So now we have our W, S, A, D, that's weird to say it that way, but whatever, all set up. And hopefully this all makes sense through understanding how we're translating the keyboard's input into game input so far. Next, we'll add the primary attack there, uncollapse this, and well, I'm going to try this out. If I click this and then left click again, oh, it works. Alright, well you can just do that to do the left mouse button. That's cool. Kind of thought that wouldn't work for some reason. I guess since it's a keyboard and not a mouse, but either way we can see it is now changed to the mouse. Right mouse button works even though it still brings up the context menu there. And this, again, is a binary button. We are going to get a 0 or 1, and it's already set to the digital bool of true or false for whether it is active or not. We don't really need to do anything special for it, at least for my case. Maybe you do for some crazy contraption you're doing. So now we have our inputs all set up. I'm going to save this, close out of all these. Now that we have the inputs, we'll want an interface that sort of matches the inputs that we have and gives an obvious interaction point for doing what we want the character to do based on the inputs. So I'm going to right click in the empty area again, go to blueprint, and create a blueprint interface. And I'll name this BPI for blueprint interface underscore character. Hit enter to create that, and we'll open this up. This blueprint interface for a character is going to represent all the functionality that our character could do from the request of the player controller. So for the case that I'm expecting, our character is going to move around, they're going to be able to attack, and they're going to be able to look in specific directions. So for the first functionality of this interface, I'm going to name it request move. And this is going to have an input of a vector 2D, because I will be working on a 2D plane with movement. I'm just going to keep it simple, and name this direction. So the character has a request move that receives a direction, allowing the controller to request that the character move in a specific direction. We'll add another function here, this one being request primary attack. Oh my gosh, request A. Then this will have another input of a type vector called target point. So this will allow a request for an attack to come in to the character and receive a point at which the character should attack. It's all pretty open-ended. The controller doesn't really need to do anything other than say, hey, attack this point, which is going to be where our mouse clicks. So if you think about a top-down shooter, we can click here, it's going to say, hey character, attack here, we'll have our projectile shoot out in that direction. And the controller doesn't really need to know anything else other than that it is telling a character to attack a certain point. Finally, we'll have a request look at. And similarly, this will take an input of a target point. Again, we can just say, hey, look at this point. The character will rotate and look toward that point. And this covers all of the basic actions that we'll need for our character. So we can compile this, save it, and close. Now it's time for our player controller. So we'll right click, go to create a blueprint class, and expand the all classes and search for player controller. We can select player controller here, select the select button, name this BP player controller. And let's open this up. One of the primary features of the player controller is going to be interpreting our mouse position to a ground position within the game. So I'm going to start off with that. We're going to create a function called get cursor ground position. The core of this function is going to be the convert mouse location to world space, which is built into our player controller. So if we right click in here, convert mouse location to world space, we have it here. Convert current mouse 2D position to world space 3D position and direction. Returns false if unable to determine value. So let's bring this in, and we can hold B and left click to bring in a branch node, and we'll use this condition to know if it did succeed or not. If it did not succeed, we can print a message for now, just letting us know that it did not succeed. Failed to convert mouse location to world space. And I like to just make these very red, as well as 10 seconds, just to make sure I cannot miss them. For the next step, we'll want to know our actor's ground location, their Z value. So we can right click, get controlled pawn, extend from this, get actor location, and we can right click this value and split the struct pin to get our actor's Z value to know where their ground location is. Next, we'll want to use this ground location to determine the distance from the camera to the ground. And to determine this, we're going to use the Z values of the world location and direction from our convert mouse location to world space. So if we extend from these and break them out, we can now have the Z values of all the different pieces we need to calculate the distance to the ground. And bear with me as this gets a little messy, we'll clean it up in just a moment. So to start off, we'll take the controlled pawn's Z location, the ground level, and we'll subtract that by the world location's Z level. And we'll divide the result of that by the direction Z. And this will give us the distance from the location to the ground of our controlled pawn. And this will allow us to know how far we need to travel the world direction in order to reach the ground from our camera. It's important to know that the convert mouse location to world space, if you were to draw a debug point, here, the point would be drawn directly on the camera, and the direction would be pointing down from the camera's point of view into the ground. One quick note, this video up here in the top, I go much deeper into the convert mouse location to world. It's in the C++ version and the naming's a little different, but the results are the same. You get the mouse location and the mouse direction, and I plot lines and points to really understand what exactly is happening in there. So if you'd like to understand this more in depth, check out that video, and if you have any questions after that, feel free to drop them in the comments. Also, if you'd like to dig deeper into any of the decisions made here, or if you have a different approach that you would take for any of this, please leave a comment below so that we can have that discussion, and I'd love to see what we can learn from each other. Additionally, if this video has been helpful, a like goes a long way for me, and subscribe to follow the journey as I continue to build and release videos. So now that we have our distance to the ground here, we can pull this out of the way a little bit. Like I said, it's going to get a little messy for now. And we can use this value here to find the point on the ground where the mouse is directly over. We can multiply the world direction times the distance to ground, and then we can add this to our world location. And this will give us the point from the camera lens in the direction to the ground, the exact length of the ground to the camera. Finally, we can return a vector cursor ground position. So in the case of true, that this succeeded, we'll return that value, and we should have exactly on the ground where our mouse is over. Now that we have this setup ready to go, we're ready to implement our interface events into the event graph. We'll be making use of both of these, so I'll just leave them here. For now, I'll want to be able to see my mouse whenever this player controller is active, so I'll extend from the begin play event and look for show mouse cursor, and there that is. So we'll set this, set it to true, so that I can actually see my mouse in the game whenever we're playing. Next, I'll right click again and do a search for get enhanced local player subsystem. Get enhanced input local player subsystem. This is the one we want, and this will allow us to bind our mapping context to the player controller. We'll move this event tick down a little bit, and we'll want to ensure that this is in fact valid. So we can pull from here, do a search for valid, choose the one with the question mark, and hook this up after our show mouse cursor. If it is indeed valid, we can add mapping context. But we cannot do it from here. We need the context, and I could add it here, but it's generally a good idea just for getting used to things to drag from the correct context, add mapping context. Get used to doing that, build the habit, and you won't have to uncheck that context menu every time. Double click the line here, make it a little bit nicer, and if you hover these over and hit Q, you can line them up. Then we want to select the mapping context that we made earlier, IMC top down, and now we should be good to go. Our player controller should now be set up to show our mouse cursor when we're in the game, as well as activate our top down context hooked up to our WASD to move the player around, or at least to send vector 2D axes, as well as the left click for the primary attack. Because we'll be using the cursor ground position for a number of things throughout this controller, I'm going to create a cached ground position, cached cursor ground position. This will be a vector to match the return result of our cursor ground position. And in the tick event, I'm going to set the cached cursor ground position to the result of get cursor ground position. And I'm actually going to set the get cursor ground position to a pure function here so that we don't need to hook up any execution pins to it. I'll plop this in here, wire this up here, and now every frame will perform the get cursor ground position once, and we'll be able to reference it anywhere else that we might need it without having to do additional unnecessary recalculations within the same frame. And because I want the character to always be looking at where the mouse is, I'm going to bring in the get controlled pawn here, and if we extend from here with the context of the pawn, we can search for request look at, and we want the message. This does nothing if the target does not implement the required interface, so we can safely send this and not have to worry about it. If they use the interface that we're expecting them to have, they can handle the message any way they want. Otherwise, they can just ignore it, allowing this controller to work with almost anything it needs to and not be explicitly tied to any specific type of actor or object. And we want the target point to be whatever the cursor ground position is. Next, we'll want to wire up our first input action. So if we right click again, input action move, we have our move input here. Event for when input action game unsorted move.move triggers. This is not guaranteed to fire every frame, only when the action is triggered, and the current input mode includes game. Tip: use the show debug enhanced input command while playing to see debug information about enhanced input. You can change what execution pins are visible by default in the enhanced input editor preferences. So I'm going to select the one with the arrow. We want the event that is triggered when the move action is triggered. And we receive a vector 2D matching our request move function on our interface. So from the triggered event, we can do a search for request move, and we get our message again, hook up our action value into the direction, and it's basically all you need. It's going to either move or it'll ignore the request if it's not something that should move. Pretty simple. And you know, I think you could probably do the primary attack on your own. Why don't you give it a try? I'm going to go on and do it now. Search for primary attack, and of course we have our message here and the events here. I'm going to select the event for the input, and I'm going to pull from the triggered execution pin, search for request primary attack message, and we'll pull in our cursor ground position here, hold control and release to automatically get the getter, plug this in, and simple as that. Well, almost. I'm totally slipping here. We need our controlled pawn to actually send the message to. And again, for the primary attack, there we go. I thought those looked a little bare. Now we're ready to go. So we're sending the message to our controlled pawn, and if it has the interface and implements the move function, it'll be handled. Same for the primary attack. Otherwise, it'll ignore it and do nothing. But we've basically got a nice little simple player controller here that's ready to work with an interface for anything that might implement that interface, and nothing has to explicitly exist for it to work. It's very decoupled from anything it will be working with. So now that we have this, we're ready to create our BP character and actually implement this and see it working in the game. We'll go on and compile this, save it, and close out. And now we'll right click again, create a blueprint class, and this one's going to be our character. So we can just select character here. I'll name it BP underscore character. and we'll open this up. We have a lot of pieces already provided to us here. I'm going to add a couple more for our case. Click the add and do a search for spring arm. And as a child of the spring arm, I'm going to add a camera. This will give us very nice camera controls to use for manipulating the camera in a lot of ways that we might want to. For my case, I'm going to adjust the pitch to turn the camera more upward to get that top-down view a bit, and the spring arm length I'm going to increase to give it a little bit wider of a view area. And I'll just leave it there for now. Not really sure what it's going to look like, but if it's not great, you can always adjust it later. So I'll compile that and save it. And now we want to implement our interface that we made earlier. So we can go to Class Settings, and in the section of Interfaces, we can click the Add drop down here, search for BPI, and we have our BPI character right here. Click it, compile, and under the Interfaces section here, we can see all of the functions that we made for our interface: the look at, primary attack, and the move. So if we head over to the event graph, we can actually remove all of these as we won't be making use of them, and we can double click on request move, and it brings in a little event for request move here for us from BPI character. And as a quick test, just to make sure everything's working as expected, let's right click to get in the context of our BP character, look for add movement input. We'll bring this in, connect these execution pins, and bring the direction into world direction. We'll compile this, head back over to our map, and in our world settings, if you don't have world settings, you can go to Window, World Settings to enable it. And I'm going to override our game mode with my BP game mode. You can just, if you don't have a BP game mode or an empty game mode you can use, you can right click, Blueprint Class, Game Mode, and select Game Mode Base. Create that, My New Game Mode. And with that created, you have the My New Game Mode. You'll have all these options you can select, and I will be using our BP character for our default pawn class, and for our player controller class, we're going to want our BP player controller. Now if we hit play here, we can already see we got several messages that failed to convert as my cursor was outside the screen. Once it's inside the screen, the viewport of the game, it's able to convert that mouse location to world space. And we can see that I'm able to move my character around. You're kind of just looking through the camera's perspective. There's no character static mesh or skeletal mesh there yet, but we can see that everything we have done so far is working. So our player controller is connected to our player character, and this is a good start for what we currently have. In the next video, we'll continue down this path of implementing all the features into the player character, and then we'll move into doing the same thing for the camera controls. And after that, we'll have a very solid player character that we can use for so many different things. So subscribe and ring the bell so you don't miss the next video. And sign up for the newsletter in the description to get access to any builds that I put out there. Go on and head over to the next video.